Hey guys, today we're going to be taking a look at ratios. A ratio is a comparison of two quantities. And with that comparison, we want to make sure that we put them in the correct order. Order is very, very important with ratios. A ratio can be written three different ways. It can be written with a colon, as a fraction, or with the word to. Our strategy that we use for ratios is labels, numbers, final. You're going to hear me talk over and over again and say LNF 222 colon fraction bar. And with our labels we'll always look back at the problem, and the problem will ask us for maybe girls to boys, and those are our labels, girls and boys. Then the numbers go with those corresponding labels, and those are directly from the problem. And then our final is where we look and see, can those numbers be reduced? If they can be reduced, then we need to reduce them, and that will be our final answer. So our first example asks for the ratio of striped to shaded squares. And in this situation, we have a picture, and we're going to take a look at the striped and shaded squares. But before we begin, we're going to write down our strategies. LNF 222 colon fraction bar. So we're looking for striped to shaded. So the question asks us striped to shaded. We need to keep it in that order. That's going to be my labels. Striped to shaded. Now I'm going to look at the corresponding numbers, or in this situation, they're squares, and I'm going to count them up. So I have 4 striped squares and 2 shaded squares. Now, I look at that 4 and 2, and I want to see, do they have a common factor? Is there something that they can be reduced by? And yes, they are both divisible by 2. So 4 divided by 2 will give me 2. 2 divided by 2 gives me 1. So that is my final answer, 2, 2, 1. And I'm going to rewrite it all 3 ways. I've already got it with the word 2. Now I've got it with the colon, and I'm going to write it as a fraction. So my answer, written 3 different ways, looks like this: 2 to 1, 2 colon 1, and 2 over 1. Now, I always have students who ask me, do we want to rewrite this 2 over 1 as just 2? We really don't. Since it's a comparison of two quantities, we're going to leave it as 2 over 1 as that fraction so that we see both components that we're comparing. My next example is a word problem. This is typically how we're going to see ratios being asked. In the parking lot, there were 10 vans and 15 trucks. What is the ratio of trucks to vans? Again, the question asks us for a specific order. It asks us for trucks to vans. That's going to be very different than if we had vans to trucks. You have to make sure to look at the problem and the way that it's asked for. So we're going to start off with our strategy, LNF 2, 2, 2, colon, fraction bar. This is just an organizational strategy that helps us to organize our work to make sure that we keep everything in the right order. So labels, we're looking for trucks to vans. So I'm going to look in my problem and see, do I see my trucks? There they are, 15. To vans, there are 10 vans. Again, now I'm going to look and see, can either of those numbers be reduced, or do they have a common factor? And they do. That common factor is 5. So I'm going to reduce both my numbers by 5. 15 divided by 5 gives me 3. 10 divided by 5 gives me 2. And that is my final answer. It can't be reduced anymore. So I'm going to write it all 3 ways. 3, 2, 2, 3 colon 2, and 3, 2, 2, 3 colon 2, and 3 over 2. In my next example, we have a football team example. On the football team, 8 special team players, 10 offensive players, and 12 defensive players. I guess it should say there are. What is the ratio of offensive players to special teams? So there in my question, it says offensive players to special teams. That's what I'm looking for. So I'm going to start with my strategy, LNF 2, 2, 2, colon, fraction bar. I want offensive players and special teams. Here's my 10 offensive, 8 special teams. In this problem, they give me extra information. I don't care anything about the defensive players. Totally extra information. So I'm filling my strategy, my organizational strategy with my labels. Offensive to special teams. I'm abbreviating just a little bit. And our offensive, there are 10 offensive players to every 8 special teams. Now I want to see if that number, those two numbers have a common factor, and they do have a common factor of 2. So 10 divided by 2 gives me 5. 8 divided by 2 gives me 4. That 5 and 4 cannot be reduced anymore. So I'm going to rewrite it all 3 ways. 5 to 4, 5 colon 4, and 5 over 4. I love that this problem had that extra information. That's one thing that you have to be really careful about. They're going to give you extra information that you don't really need. So only focus on the information that the question asks us about. Okay, and our last example says in Miss Miles' class, there were 10 boys and 14 girls. 10 boys and 14 girls. What is the ratio of girls to total students in the class? So when I look at this problem, I'm going to start off. It clearly says we're looking for the ratio. So I know my strategy is labels, numbers, final, 2, 2, 2, colon, fraction bar. And it asks me for girls to total. So in my problem, it's very easy for me to find my girls. It's 14. Now, the total, it doesn't come right out and tell me that there are this many total students in the class. It tells me there's 14 girls and it tells me that there's 10 boys. So we have to calculate the total. We have to use our reasoning skills and say, okay, if there's 14 girls and there's 10 boys, that we know that there's a total of 24 students. And when I look at those numbers, 14 and 24, I want to find, is there a common factor? And there is a common factor of 2. So that's going to give me 14 divided by 2 is 7. 24 divided by 2 is 12. And 7 and 12 do not have any more other common factors. So I'm going to rewrite it all 3 ways. 7 to 12, 7 colon 12, and 7 over 12. Okay, we've seen ratios written 3 different ways. We've talked about a couple different ways that we could have to calculate ratios. And hopefully this strategy will help you to whenever you're having to find ratios in a problem. See you later.